Greetings, everyone. Our project is C4C Dining Inventory Management. My name is Shiva, and my teammates are Chiranthan, and Pritham. Next slide. Okay, so our project goal is basically to create infrastructure to manage the logistics of a large-scale dining services center like C4C. We have lots of restaurants in C4C, which could be of very different cuisines like Italian, Persian, Asian, etc. And what we basically have is represent all of these restaurants as stations here, and each of those stations have a stock or an inventory, and when they run out of that inventory, they make a request to the C4C center, which procures raw materials from grocery stores like Walmart or Safeway, etc., and gets inventory to these stations. Next slide. Okay, like I was talking before, we have to, in some format, represent the stations and their stocks, and we have to give the ability for stations to make inventory requests. The C4C station server aggregates all of the stock requests that it gets in a day and places the order to the grocery stores. And we have to somehow represent the grocery stores with a bunch of inventory, which basically take orders and process the orders um, back. And we also have to implement the station servers to optimize the order placement to save some money. So basically, it has to search for the cheapest available place to buy the products from and order it from there. Next slide. Now I'm going to hand over to my friend Preetham to explain the architecture part.
Yeah. So coming to the architecture diagram, we have a couple of components which I'll explain briefly now. We are using the Redis list, the MongoDB, MySQL, and the Docker as well as the Kubernetes. Coming to the left side, you can see there are three station DBs shown. They are all separate entities which are storing all the pantry items, and they place requests based on whatever they require to the station server, and the station server logs it onto the request queue. And the request worker, which is essentially a scheduled worker, looks at the request every day at a point of time, probably in the midnight, so that it places the order back into the store. And it has the ability to check what all items does the store have and the pricing for that. And based on that, it places a very cost optimized order back into the store. And after the order is successful, it places the final order details back into the audit DB to check if everything went and to revert back transactions if required. Along with that, we have the request worker putting the order back onto the restock queue, which is basically the Redis list. I'll explain that in a while. And the restock worker basically looks into that restock message queue and fills the items back into the station for all of the orders which have been placed. And this is how our architecture works. I think the only thing is we have the logging queue, which gets messages logged from each of the components, and all of those will be displayed separately. Going to the next slide. Yeah. Uh, Coming to software and hardware components. The software components we use are Docker containers and Kubernetes, and we have the Redis lists which we are using as message queues. We have three Redis lists which we are using. So the restock queue and the request queue and the logging queue, and the MongoDB key value store, which is used as our audit DB to store collections of items and the prices along with the final order. And the MySQL database, which is used by the station and the store DB, where it stores what all items it has and what all items it can sell. The REST API interfaces are basically the API routes we use to interact with between each component using HTTP. And coming to the hardware components, we are deploying the system onto our local Kubernetes, which is given the RAM of 8 GB, and the ROM has 256 GB of internal memory. Go to the next slide. So when we talk about testing and debugging, the various kinds of issues we came across are coming to the microservice unit testing. We have a couple of components like the store DB, the station DB, and the request queues and the message queues. All of those needed to be tested separately since there were few issues coming up with the deployment of them. And coming to the message queue integrity testing, this is where we check the order and logging of messages, and if the request has been placed in the right place and the right time. Uh, because we were facing a few debugging issues where we looked at several components not being able to pick up a message on the message queue. That is because some other component had already popped it out. And coming to the database integration testing, this mainly dealt with the structure and the way we could deploy the MySQL database as well as the Mongo database. We had to use a NoSQL format for the MongoDB, while MySQL had a strict, rigid structural relational database. And coming to the REST API testing, we had to check if the request and response were being fetched appropriately. And the response has to be JSONified so that it gets passed through HTTP using the content type as JSON. And the Redis logging queue debugging, this is where we were checking which of the operations were being performed by each of the components. And because of that, the logging debugging, we were able to figure out what kind of issues were being faced by each component there. And going to the next slide,
Okay, thank you, Preetam.
this would
Let's
be
move
our
on to
demo
the
with
demo part two.
Chirantan will take care.
Hello, everyone. So we are running our project in the Kubernetes cluster in our local system. Let me show you all the microservices that are deployed. Hello, type get deploy, and these are the different components of our project. All are deployed in the same namespace as of now. We also have one more additional component, which is schedule-based worker. We'll try to list down that as well. And this is the shell worker. Preeta was mentioning that we'll be running the request worker every day once, which is 24-hour once. Just for the demo purposes, we are just making it 1 minute one so that we are able to see the messages fast. Let's move on to the request part. So before that, one point about a component called logger. So this is a standalone microservice that we're using to stream all the different interactions and transactions happening in our project. Let's try to run that and um, stream all the logs. So the logs are already there, but let's try to create a request and see what happens. We are using request server to which is the starting point in our whole system. So you'll be placing the request as a station from the request server. So we'll make a simple health check endpoint to make sure that the system is up and running before we place the actual request of getting an item from the pantry. It's running the 5000 port. We have exposed a local load balancer, so we are able to access it from the local network outside the Kubernetes cluster. We are getting a response saying hello world, so that means that the system is working fine. Now we can actually place the request for getting an item from the station. As mentioned before, you will have to place the request from a station, which is currently either station 1, 2, or 3. So you'll be saying that I want to request something and I'm from station 1, for example. And then you say which item you want to request. Let's say it is Apple, for example. And then you'll say how many items that you want to request. So this will give a message based on the number that you place. If the item is present, if the number of items requested is present, it will say the request is processed. That means we are able to get the requested item that we want. We are also able to see the same in the logger streaming. The request for one apple was placed and it was successful. But it also says secondary message. What that is we are looking at it right now. Self requested for one apple in station 1 as it went lesser than threshold. So we are using a threshold of 5 for every item in every station. So if an item account goes below 5, just to make sure that we are not very low on stock, we are requesting automatically on our own to refill it, and that is this particular message. This is currently placed on the request queue, so it's not processed yet. It should be picked up from the cron worker. As we mentioned, it runs every 1 minute. And as you can see, some new logs popped up. That is from the cron worker, as it mentioned here. The cron job started. The job of this particular worker is to take all the requests from the queue, and that is what it is doing. Before actually processing the request, it makes sure that all the logs, all the transactions that we are doing is placed in the audit log so that we can see them later for debugging, for example. It sent the request for the restock queue and the grounds are bended. That's the end of its job. But now this request is picked up by the restock worker that does the actual job of restocking. And as you can see from this message, it added one apple to the station one and current count is 5, which was initially 4. And that's basically the whole sequence of our system. And we have used MySQL, we have used AuditDB, MongoDB for audit. We can just look up on one of the databases. So I have just opened up a client for MySQL here, and I am in the station one. As you can see here, these are the different items present, and this is the format that we use for the database. Similarly, we also use specific format for audit. Just for time purposes, I'm just showing it here. We use the ID, the timestamp that it happened, which store, what is the number of items, what is the total amount for it. Similarly, for the other collection in the audit DB, we use similar formats, but we also say what was the total price, what was the quantity, what was the order ID that was used, which is right here. So that's basically our components and the sequence of steps in our system. Thank you so much. Have a great day.